Hi, I'm Hw10. This is my homework video for the homework 10. And for the question, we need to illustrate some definition and simple property of the stochastic process. The first example is the Poisson process. So first we know the general definition of the Poisson process is the probability of number of chords in the t. This is the t means integral, and that's equal to k equal to the e to the lambda t and lambda t to the k over k. So the lambda is actually the density of the density of the chord in this integral. So what if the integral the time t, I mean the integral is not fixed? So the number of the chords in the t is a stochastic process. So first we need to know some property of this. The first is that x0, which means the number of the phone calls in t equal to 0 should be equal to 0, and the xt1 minus xt2 is equal to the number of calls received in the integral t2 to t1. So with this probability is equal to this equation. So its property is that the point in the non-overlapping integral are independent. So for example, if td smaller than tc smaller than tb smaller than ta, so td to tc and tb to ta is two non-overlapping intervals. So these are two independent. So we can know that the left part equal to the right part is equal to the right part. So, and the second question is that the mean of it is equal to lambda t. So it's easy to prove based on our old knowledge. Is just using k to the 0 to infinity equal to 1. This is a distribution, the property of the distribution functions and the density functions. So first you differentiate with the lambda t and multiply by the lambda t, so we can get that the mean of xt is equal to lambda t. And the property 3 is that the correlation is that the r t1 t2 is equal to the lambda square t1 t2 plus the mean lambda multiply the minimum of the t1 t2. So in order to prove it, so we based on the formal properties. So for this equation, we differentiate by the lambda t and multiply by also lambda t. So we get that the k from 0 to infinite k square lambda t to the k over k is equal to the lambda t plus lambda square t square multiplied by the e to the lambda t. So here we know that the mean of x square is equal to the lambda t square plus xt square. So using that the two non-overlapping interval is independent. So we divided x2 equal to the xt2 minus xt1 plus xt1. So these two parts are independent. So these two parts equal to this one. So these two parts we can easily according to the property 2, we get is the mean, and the last part is the mean of x squared t1. So according to this equation, we get this. However, the final result is lambda squared t1 t2 plus lambda t1. So this result is based on the definition. It is based on the assumption of t1 smaller than t2. So what if t2 is smaller than t1? So this last part is equal to t1. So the final result is equal to lambda multiplied by the minimum of t1 t2. Okay, the second example is the Poisson increment. So this is its definition. Poisson increment equal to the yt is equal to the xt plus sigma minus xt over sigma. So if the n is number of cores in t to the t plus sigma, then the probability of yt equal to the n over sigma equal to the e to the lambda sigma to the n and over the n. So the mean of it is we can easily get, and from the last property we can get the mean of it is equal to the lambda. So the ry t1 t2 equal to the e of the yty yt2 is equal to this. So you need to make sure that these two parts are independent. If not, so you need to find a way to it. So first we assume that t1 greater than t2 plus t sigma. So these two are independent. So we get the result of lambda square. So in this part is also lambda square. So in this part they are not independent. So we get the result of here. So basically this part is because we need to know if these two are independent. So first we get the result t1 t2 equal to lambda square when t1 minus t2 greater than sigma, or if the t1 minus t2 smaller than sigma is equal to this. So actually this part is the usual correlation function like this, blah blah blah, like I had. You really need to know if they are independent. If not, you need to use this technique. You can see the minus xtc plus xtc to get this done. The third example is the Poisson imports. So this is its definition. The Poisson import is the differential of the xt is equal to the elimination when sigma equal to 0 or yt. So the mean of it you can easily get is equal to lambda, and the correlation is equal to the lambda square plus lambda import of t1 minus t2. So the first example is the semi-random telegraph signal. This is its definition. So xt is equal to 1 when k is even in 0 to t. Also xt is to minus 1 when k is odd in 0 to t. So this actually we did this in the homework 9. So I don't want to say this very detailed. So the probability of xt1 is equal to the e to lambda here, and the probability of x2 minus 1 equal to here. So the mean of it, you plus this, and finally you get the e to the minus 2 lambda t. And the correlation is the e to the 2 lambda t, t1, t2 minus t1. So this is in the homework 9. Yeah. So the fifth is the random telegraph signal. So let alpha be a random variable independent of xt with the probability of alpha equal to 1 equal to the probability of alpha equal to minus 1 equal to 1 over 2. So yt is equal to alpha xt, then 1t is the random telegraph signal. So the mean of it is the mean of alpha xt is equal to the mean of alpha multiplied the mean of xt, which is equal to 0. Because the mean of alpha is the minus 1 over 2 plus minus 1 over 2 is equal to 0. So the correlation is equal to the e to the 2 lambda absolute value of t minus t2. Okay, the sixth is the random walk. So this is its definition, and the mean of it is the minimum of the n between n and m multiplied by s squared. So the correlation of this static process, I didn't find it in the lecture, so maybe I can talk this later. So here is the seventh example, the winner process. So we define the winner process as the limiting process of the random walk. So Wt equal to limitation of x equal to 0, t equal to 0, n n to the infinite xt. So for random walk, the mean of x squared t is equal to the n multiplied by x squared. So for the winner process, the w squared is equal to the alpha t. So the density. So this is a density. So it's a normal. So the mean of the winner process equal to 0, and the correlation is equal to the minimum of t1